Hi all, welcome back to the channel. My name is Aseem Singhal. Today we are going to use the auto Arima model to find the PQD parameters on its own, because this was the issue that we found in the previous video. So if you have not seen the previous video, you can see how we use the Arima model to predict stock prices. But the issue was that we weren't able to get the right parameters. So for that, I'm going to use auto Arima now. So the main aim is to use auto Arima to find the P, Q and D parameters. So again, we'll do the pip install. So if you have not done it, what you have to do is just do pip install pmd arima. Since I already have it, I'm not doing it again. And let's import all the libraries. So we'll be needing a few. So first we'll import pandas, numpy, matplotlib, I'm just going to import warning and make it ignore later, and then I'll be using the stats models, from which I'll be importing the ACF and the PACF. Similarly, I'll be importing Arima now. And then we just have to import the date time. And I think I'll be requiring time as well. And finally, I'll just import the auto Arima. So we have imported all the libraries. Now I'm going to just go for the warnings. I'll just be ignoring all the warnings now. So we've done this. Let's run it to make sure everything is right, and it looks fine. So let's start with getting the data. So I'm using the same CSV. So I'll be importing the CSV first, and let's call the data frame as df is equal to pd dot read underscore CSV, and I will be reading my NSE, the index data that I already use, that I always use. And I always like to pass the date so that I can use it later. And we just try to interpolate it as well. So I'll be using train data and testing data. So for training, what I'll do is I can probably use till 2020, and all the data since 2021 first Jan I'll use it as the training data. So all I have to do is I'm just splitting up my data frame. So I'm just splitting up my data frame now, and this becomes my test data is equal to, so let me just copy this, and everything from 1st Jan I'll take it as my test data. So let's just print it out to see if everything is fine. So I'm going to print out my train data as well as the test data. So the data looks fine. So you can see here I have since 2017 till 2020 I have it in my training data set, and the remaining I have in my test data set. So we've got that, and the data has OHLC in the columns. So the first thing is we want to make the auto Arima model now and find find the parameters. That's what we are looking for. So to do that, let me make a variable called model is equal to auto underscore Arima, and I'll be putting the training data set first. And let's say I'm using the closing columns. I'm going to put that seasonality is true. So that's one of the, again, you can use true or false. This generally depends on the kind of data that you have. So if you have MCX data, this can be really useful. And then I'm just putting all the different things that we need to put in this auto Arima function. And I'm going to suppress all the warnings as well. And once I've made the model, I'll just fit it as well. So I'm going to fit my model on the, again, the training data set. And let's print it out. So I'm going to print the fitted dot summary. Let's see if it works. So this might take a little bit of time. So what I'll do is I'll stop the video here and I'll restart it. So it has been able to figure out the different parameters. So what it was doing was it was just doing different parameters and checking what is the best fit. And what it found out was that the best model is 312. So it's telling us that the best model that it's getting is 312. It is also telling you what is the z score, whether the p is greater than z score, and standard coefficient. So everything is mentioned here. We'll be going through all these things in our separate videos. What does Leon box means? What does Jacob Barbara? So all this will be going in detail later. But essentially, what this function has done is it is able to find out which is the best parameter for the data that we have. So now what I'm going to do is let me just forecast the data. So I'm going to predict the prices for the next 20 days, for example. So to do that, forecast is equal to model.predict, because our model is already created, and all we have to do is n underscore periods is equal to 20. And if we print out the forecast, let's call it forecast 1. Let's see what comes. So it is able to give us the results for the next about next 20 days. So what I want to do now is, let's say if I want to run the model and predict it for next 2 years of data, and whether we should be buying or selling it based on the predicted prices. So how can we do that? So I want to run the model and predict for next 2 years, and based on the prediction I want to buy or sell. So let's do that. So I'll just use the P by TZ library here. I'll be using some empty lists. So I'm making my test data dot index to list. And I'm just adding the timestamp. Just want to make sure that it's in the right format. Why I have to do that is because I'll be using some offset here. So that's why I'm doing this. So let's try to create our results now. So first thing is we want to create the Arima model, in which I'm going to put my training data set on the closed column, and I'll use the same order that was predicted earlier, which is 312, which is here. So I'm using this 312 to create my Arima now, and I'll just put the seasonality order also. So my seasonal order is again 1 comma 0 comma 1 comma 5, if I'm not wrong. Let me check. Yes, so this is my seasonal column 1015. So looking from the auto Arima, I am able to get my parameters. So my model is created. I'll just fit now. And let's find the next day price. So my next day price is equal to my model's forecast for the next day. Um, and because we will need the only the latest data, because fitted forecast gives you for next X number of days. Since I will only use the next day currently, so what I'll do is predicted price is equal to next underscore day price, and I'll just use the first value here. Once I've done that, let's put the training data set also. And now what I want to do is, if my predicted value is, let's say, less than the closing price of today, that means I want to sell it, right? So that is my prediction. So if predicted price is less than the, say, the training data's previous value, so I minus 1, and let me just convert it into the correct time frame and the correct format. Right. So what I'm doing is I'm checking my predicted price. If my prediction says that it's going to be less, so tomorrow is going to be a downward day, what I'm doing is that I'll put my direction as sell, so that at the closing price I want to sell Nifty. And let me just I'll just append my data. So let me be a little careful here. I'll be using the date, which is the same index, which is here. I think I've made a mistake here. This shouldn't be train data. This should be index. Yeah, now it should be fine. And right, so index of I minus 1. And what I'm going to do here is just take the same thing till here. So we've got our date. The second thing we need is the day. So it will be percentage A. The third thing we'll require is the current closing price, which is my train data. And again, let me just paste everything from here. This is my current closing price. and let's say I print out my next day closing price or next day price, which is again my using the training data set, but not I minus 1. This is the actual data. And then I can print out my direction, which is direction directly. And let's finally print out the predicted values, which is predicted underscore data. So I think that should be good enough. So we have got all our data points that we require. So this is in case of selling, and if this is not the case, that means my predicted value is not less than, then I'll be buying it. So let's put an else, and direction is equal to buy. So what I can do is, let me um, take this append out so that I can do it directly for both my um, both buying and selling. So let me just take this out, it will be much easier thing. Now it should be fine. So we've got our direction, we've got our um, all the data points, and once we have done that, let's just finish the accept. Okay, so basically what I'm trying to do here is, we are trying to get the results, make a model using 312, which was predicted earlier, and the 1015 using the auto Arima model. Then we fitted the model and we found the next day price. Once we've got the next day price, what we're trying to do is, we're finding the current day price, and this is the, you can assume this to be yesterday price. So based on yesterday price, I want to predict today's price. If my today price is less, that means I should be selling yesterday, because I want the market to fall. So that is why my direction is fall, otherwise the direction is up, buy. And then I'm just adding everything in my data.append. So once I've done that, let me run it. I think it will take some time. Okay, let me check what is the error. Okay, I think I've not put in. Okay, I think there'll be more. Yeah, let me just make these corrections. Okay, let me run it again. Let me check if it's fine. Okay, still giving some error. Okay, let's check again where the error is. Data.append. You have the right date, index, YMD. Then I have the day. Let's just remove the day. Okay, probably here. Okay, let's try it again. And okay, still giving some error. More name index is not defined. Let's see. Okay, I found the mistake. This is in line number 8. Okay, let's try to run it again. And now it's giving me the error of order in line number 9. should be fine now. And now it's trying to get the result, but I think it's still getting some error. Let's just try to figure this out. Dot values, and too many errors. Okay, data is not, it's not appending, but we did make the, okay, now it should be fine finally, and it is able to run. I think predicted underscore data is not defined. Okay, which this is in, okay, let's see. This is predicted underscore price. So I think this is a good way to actually, you should also understand how we can do debugging. So this is not data, this is price, because I've used predicted underscore price here. So let's run it again, and now it is building up. It is building up. So what I'm going to do is, um, let it give out the results, and I'll restart the video once I've got the results. So it has stopped running. Let's see how the data looks like. So this is how we get the results. So for example, it tells us for a particular day what is the day, what was the current day closing price, and this is the actual next day closing price. So let's take the first example. This is, let's say, today's closing price. It predicted that market is going to go up, and the predicted value was 14034. The market actually did go up, right? As you can see, we closed at 13967. As per the predicted value, market was supposed to go up, so we could have bought it and we would have ended up making a profit. Similarly, let's take this example. So today also, the value is, the current closing is 14015. It again predicted that the market can go up, and next day again the market actually went up. So this is how we can do the analysis and do the prediction for the next day. So let's also just quickly try to make a graph to see how it looks like. So let's plot a graph now. So let me just put in the current prices, and the original prices as well as the predicted prices. So the original price, we already have the data. 1 second, it's saved in this. We have already got the data here, which is in underscore df. So we already have that in underscore df, but since in that we had indexed it with minutes, let's index it with day now, with date. So let me just copy it again. So instead of minute, I'm going to index it with the date, and plt dot figure, and now I'm putting the test data also, text data dot close, and let's put plt dot plot. And in fact, what we can do, right, before we do this, we can actually store the data in a CSV file. And once we store the data in the CSV file, then we can plot it easily. So what I'm going to do is, let's just store the data in the CSV file first. So import CSV, import OS, and we have our headers, which we have already created earlier. And so let's just check if we already have the file, and let's call it NSCI underscore stocks.csv. I'm opening it in the A mode, and I'm just adding the new line. So what I'm doing here is I'm just saving our data in the CSV file. Writer dot write row and row. Else, if we don't have this, then we will open it as a W. I'm just going to copy it here. So this time what I'm going to do is I'm going to open this as a W mode, and everything else would remain the same. So let's quickly run this. Let's see where it is getting the error. Dict contains field which is in field and predicted value. Okay, I think it's asking for this predicted direction. What was the name that we had used earlier? Let's check. Predicted direction. So looks correct. It looks correct. Let me just, okay, there is prediction direction. Okay, so I think that has saved the file. So that must have saved the file now. And now what we can do is, now let's try to plot the graph. So plotting. So let me make another df, which is pd.read csv, and I'm going to read the NSII stock that I've just created. And now I'm going to use the index column as date, and the parse dates is true. plt.plot test underscore data dot close. That's the testing data that we are trying to plot. And I will first plot the predicted prices also. So I have the predicted value, and then we can just give it the legends. Original price, comma, predicted price. So I think that should give us the solution that we're looking for. Let's run it. Okay, let me check where date does not exist. Let me check. NECI stock.csv. Let me see if my if it actually saved the file or not. So I found the error. Actually, I had not added this header. So let me just run this again. Once I run it, my header is now saved, and now I can run the file. And this is how this is only the test data, and you can see the predicted price and the original price. There seems to be one erroneous data point, but that's okay. You can clearly see that the original price and the predicted price is very close. So it has been able to give a very good prediction using the auto Arima model. So I hope you like the video. Do subscribe to the channel, and do like the video. Thank you.